or pardon, yeah, 4 is, whenever you think day ends. There's some variability there. Most people would say the day does end before, that everybody goes to work the next morning. Yeah, there you go. Anyway, this one's, I think it's working pretty well. Mostly when people show me this now, they've got the memory leaks all fixed, and they're dealing with a few other errors. There's one very funny thing that's happened. So with the memory bugs added, it only saves 124 files instead of 496. Most semesters, as soon as everybody's got that fixed, memory errors, it starts saving 496 files instead. But somehow, this semester, that's not actually what's been happening. And I haven't really looked into it and figured out why. I suspect that perhaps one of the solutions is either leaving in place a memory bug or introducing one of this sort. So if you got some area here, and you try to access some spot like that, invalid write will tell you invalid read, or invalid write. Depends on how you're trying to access it. If you try and read from here, you get invalid read, otherwise you get invalid write. Now, there's a different memory area over here. And you're trying to say this is A, and this is B. And this here is location 10, A at 10. Okay, so that gives you that error. But, say this location here is like B at position 5, but it's also like A at position, I don't know, that's 10, maybe 25. Like way past the end of that one, you see? But it's legitimate in the sense that you're actually reading from memory that's been allocated there for that purpose. It's sometimes possible to trick valgrind by doing things like this. So I suspect that there's a memory bug in there that valgrind is probably not finding. In a grade sense, I'm not that worried about it. It may be imperfect, but it's not all that bad either. I would expect that it would work decently well. The leaks are the biggest thing. If you can get it down to no leaks, then that's the lion's share of the credit for sure. Anyway, that's be as it may. So that's how that thing's working. I don't know if anybody's got this fixed so that the memory error actually goes away completely. Are they?
Yeah.
Okay. Well, I don't mean to make you feel like you're the first
Good on
person
the
to
leaks,
have that
but
problem,
the errors, no.
Anyway, that's this is going on in the before there.
Yeah.
So, it's in there somewhere. I guess I wouldn't lose any sleep over it if I were you. Okay. So that's project 4. Do at some point. That'll be fun. So then project 5. So I just posted it this morning. I actually just made this one up the other day, and you can actually move the mouse around from inside the kernel because you can have device drivers, and so therefore you can report input at any point you like. So therefore you can make a module that allows you to move the cursor wherever you like. We'll be supporting Linux users here primarily. They're the ones that are most likely to lose the mouse somewhere. It'll be a Linux kernel module. So what you got to do, make a kernel module that allows the keyboard to be used to control a mouse by moving it with the arrow keys and clicking on the pause button. So that's what we'll talk about today. How do you make that happen? Class rate, CS430. Today, I put a lot of notes in here that I won't necessarily remember verbatim. So the biggest question is how do we control the mouse? So the mouse is an input device, and as is usual for stuff in the kernel, there's a struct input dev, and the struct input dev allows you to control it. Okay. So we get to Linux source 4. Okay. Sorry. Probably when I have a cold and my throat doesn't work right, I can't type either. We're looking for this struct input dev. Dev device. Yeah, I thought it was input device. No, input dev. It's all over the place. Okay, curly brace. It looks like input.h. Okay. So there's a struct input dev. And it's got a lot of these bit fields, EV bit, key bit, rel bit. And so there's, these are just like a little set of numbers there that's used to control stuff with flags. So you've got bits and, you set them and they turn stuff on and off. We'll end up using EV bit and key bit and rel bit. I don't think we'll use any other bits there. But they're used to set properties of your device. So if you're going to have an input device, see like a keyboard's an input device, this mouse is an input device. And the mice have variations if you ever look at these things. So this one, for example, it's got 2 buttons up here. I realize this is unfamiliar to Mac users, but the second one, it brings up like a properties menu or something like that. And then you got this wheel in here that you can turn. And if you push down on the wheel, it clicks another way. And on this particular mouse here, it's got these buttons with these arrows. And if you grab it wrongly, you push these things. I don't know what they do. Really nothing. Oh no, they do something to Vim there. Got these extra buttons on there. And depending on which mouse you have, it may have a lot of extra things. And some of them have different configurations still. For example, this one here, it doesn't have a wheel anywhere, but it's actually got 3 buttons on the top that do things. This one here, I think this is a normal mouse. Yeah, it is. It's just got the 2 buttons and it's got a wheel. But then this one here has 3 buttons along the side. I don't know what they do. This is a wireless mouse. Oh, it's got another button here too.
A lot of them are programmable.
Yeah, in some cases.
I think that extra button in the middle there is the DPI setting.
Oh, that one?
Yeah.
Okay. Well, anyway, they have different numbers of buttons. And so you can set this stuff all up using these fields here and say what exactly your mouse does. So that's those things. Okay. So UV bits, miscellaneous bits, LED bits, etc. Okay. This truck goes on for quite a while. There's a bunch of stuff in it that we're not really going to use. And yeah, there we go. Okay, so I'm actually making a little demo with this thing. So we have a bunch of tasks we have to do when we set up the mouse. A little bit less when we move the cursor and click. And then we've got when we remove it, we have to remove our kind of mouse device here in the kernel. So, I think that's kind of way I like to do this. I'll just put it in here and hope to copy it later. Okay, so we're going to make a module that controls the mouse. So I'll call this mouse controller .c. Okay. It'll need some include files at some point, but we need to have an init function. Okay. The usual profile for the init function, we cat say blink.c. Let's see, init has void here, and it's static int whatever. Actually, we should just go ahead and grab this one. It's probably blink.c to mouse controller. A lot of times it's easier to just start with one of these things and get it. It isn't anything else. We don't need that. We don't need that. I don't think we need any of this stuff here. Probably don't need that. Don't need that. I don't want the timer. Don't need that. Don't need that. Don't need any of that. Or that. Oh, let's do on the timer later. I'll go ahead and gut it and leave it. That's how you make a timer function. Okay. Don't really need any of that unless you want to keep how you make a timer work. Or that. Or that. Or that. Or that. Okay. KVLETs is like not a very good one. Good name for this init function. Okay, MM for mouse move. What about clean up? Okay. I did that wrong. Sorry. It's over that much. Like I said, when I recall, I can't use a keyboard. Okay. So the timer stuff isn't going to do anything right now. We'll just preserve it in case we want it in a minute. I think we might. Okay. So this is it stuff. We need a struct input depth. Okay. It needs to have some kind of name. We'll say this is our mouse or extra mouse or fake mouse or
K-mouse,
a mouse,
keyboard mouse.
a mouse or Gary or whatever we want to call it. Okay, I actually kind of like that. I'll leave that. Okay, I'm making a point of this mouse. Over here, you have this input allocate device. So the way input allocate device works is it actually makes one of these structures for us. And so if we look up input allocate device, so we'll find documentation for it, stuff like programming input devices. And so there's an example of how it works. There's a number of examples that will help pull this thing together from various places. So here are like how these things work. This one makes an input depth. It looks like it requests an IRQ, so they're talking about an actual device, but you know, it's fine. Okay, so our device, it's allocate, input allocate device. Okay, so now we got one. So what's next? We got a name property. We can't ignore it. And so it has to be named something. Okay. So then set bit and setting bits. Set bit is a function that sets bits. So if you have in this case, it's actually kind of a long array of bits that are stored as some kind of number, and you don't feel like doing masks and shifts and things, you can use set bit. The other thing about set bit is it's actually atomic. And so that could be good if you had two of these loading at the same time, as opposed to doing a mask it and save it kind of operation. Anyway, regardless, all the demos I've seen use it. Oh, but this one does not, actually. Interesting. Okay, all the demos I've seen for it, except for this one, actually use set bit. You really don't have to use set bit. The other way you can do it is just do a bit mask. You can do something like this. We just go ahead and set this to. We'll go ahead and bit mask off the EV key, and it goes. That works fine. Or you can construct the bit mask all on your own if you want to. I just set bit here. So I guess I'll call that then. A few things we have to set bit on. EV rel. EV rel. So you can have either a relative or absolute kind of device with pointing. If you have a relative device like the mouse, it means that it gives you an offset from what it used to give you. So when you move your mouse, the cursor moves from its old point, not from a brand new point. Weirdly enough, touchpads actually work the same way. It gives you an offset from where it was before. You just grab it and move it. Trackballs, of course, same thing. Now, if you had, say, a touch screen, when you touch it, you're giving an absolute position. This is where I want to click. So in that case, we would not want to be setting this up as a relative device. Okay, so whatever we call our device.edbit. And I wrote dot in my notes, but you can see Jerry is clearly a pointer, so we're going to have to use the arrow instead. Okay. So then rel x and rel y, sure. Rel bit. Okay, we're going to set up both axes as relative. I don't know if there's a rel z. Didn't try it, probably is. So then the buttons and setting the buttons. So I had trouble with this when I was setting this up to test things out and learn how to do this yesterday, because I kept not putting buttons onto my fake mouse. And if you don't have at least one button, it doesn't appear as a mouse, and so it doesn't get registered in the mouse input system properly, and then it doesn't work. So whether you want to click buttons or not, you need to have at least one button or it's not a mouse. That seems like a little bit odd logically. It seems like you have a mouse that doesn't have it. Can't show you an example of hardware like that. show you one with a broken button. Okay, so two more. ED key, ED key. And which bit are we setting this time? It looks like an ED bit. Again. Okay, then the left. Okay. This is like key bit, I think. Okay. So there's an occasional key term here, and it does have the same thing as the key, where you get key down and key up, and they're different, like a keyboard. And you know, you can tell out on the mouse. So I grab this mouse here and I try and click, and now I'm moving it. You see, it does something different with click and drag. So it has a down and an up. Okay. So once we've set that, we can register our device. I think this takes the address of our device. I didn't really write that down on my notes whether it did or not, but hopefully. Okay, so at that point it ought to be registered. So now if we want to, we should be able to, oh, we got to unregister too. Let's go ahead and unregister it. Okay, that's input unregistered device. Okay, pretty straightforward there, really. Sort of what you'd expect. Okay, so once we did that, we can input report rel, but we have to do a sync as well. It's doing that. We look over here. There's where we do a key here, button interrupt. So when a button interrupt happens, they're registering an actual IRQ handler here, and put in the beginning is a real mouse driver together in this example. But you can see the input report key, then the input sync. And you have to do that in order to synchronize whatever you have there on the input. This in-B thing here, this is an in-bus. So if you want to actually try and read off of a bus, we're not trying to read off of a bus because we don't actually have a hardware device. And so we won't be doing that. Okay, so input report. That was report key. We don't necessarily want to do that. We could. Let's go ahead and move. Import report rel. Okay, so then we need a device, and then we need the where we're going. Like click access, and then we need a value. 100. Sure. Playing with this 100, moves it away. Remember, this is an input report. It'll later be interpreted by the graphical system in order to correlate that with cursor motion. So it's not necessarily going to have a one-to-one correlation with pixels or anything else. But it is a value where a higher number you'd expect more mouse movement from. Okay, so there's that going to sync. So I didn't write that down there, but let's write that here. Input sync. Okay, and then our device, I think. Yeah. So they've got a pointer to it. They just pass in the pointer here, so that's probably how. We're not an IRQ handler, so we don't say anything about IRQ handler. Okay, we're going to need, I think it's input.h. Okay, let's see if this thing at least builds. Okay. Okay, it built. Cool. Okay, let's try inserting. Okay. So there's where the cursor is. Put it right on that dollar sign. Oh yeah. Oh. There's a password for wrong computer. Okay. Well, the whole hiding it thing is really not that great here in this context. Maybe I make my terminal smaller and put the cursor down there. Okay. Okay, that totally didn't work. So we didn't register it. Oh, there's a name. Or it's got a name, set of relative. We put those sets. We got that set. We gave it a report of the motion. I wonder if there's some problem with doing this in the init function. I didn't actually test that. And then we input sync ditch right there. And then we immediately register it. It seems like that should be fine. But let's go ahead and throw it into a timer function here, just so that it happens significantly after it's been registered. Okay, so now it's there. Don't need to return, it's a void function. So then this part down here, this pretty much goes as it does. It's got a blink delay there. 100, favorite number today. I think it's still called my timer function, which is good. And then we can want something like that. And go up here to reset the timer. And then down here, we don't actually need that data, and we don't have it either, so it's fine. Okay, try that. Yeah, I did. Okay. Okay, that's fine. There we go. Off goes the cursor. Drop it right next. That could be actually really irritating. Click on something, you can see it keeps moving.
It's just running away from you.
Right, it is. Yeah, now it's off on the other screen. It's going to keep wandering over to the other screen.
What's making it wonder?
So, yeah. Eventually it'll come to rest on the far side of the screen. Okay, so we got this timer here repeating this move. And so every 100 jiffies, we're moving over by 100, whatever that is. And
Okay.
so off it goes.
Got it. I must have missed that line.
Well, I put it there because it wasn't doing it when I had it in init. And so apparently you can't just move it in the init and then expect it to work. You have to give it a moment to have actually registered or at least complete the init function. That's moving the mouse from the kernel. And if we wanted to, every time this happens, we could also click. So we could say input report the key. Okay. So then the whole clicking thing. So I can actually, I can use this thing, which is busy wandering. I can actually, so we can say input report key down there. We can say which keyword we want. Okay, so Jerry, VTN left, and the state. So it can go down or it can go up. So we can set a state here. We can say something like char state equals 0 to start, and then this is state. And we can switch the state back and forth. We can say a state equals not state. Okay. So let's go ahead and remove the module. Now when we do that, the cursor will stop moving. Uh-oh. Actually, there's a problem. My keyboard lights have started blinking and the computer's dead. So the problem is we forgot to cancel our timer. So yeah, the timer, as soon as it went off after the module was done, we had a problem. Okay, well, I don't have any options at the power button now. You know, the weird thing is, I haven't actually locked up my machine in my office this semester. I was looking at it the other day. The uptime dates from before the beginning. This is a definite first for teaching this class.
That's because you make all the mistakes and lock up the computer here in this room.
Well, I spent like a lot of yesterday afternoon playing with this mouse thing. I think I make a lot more mistakes when I'm busy trying to explain what I'm doing at the same time. Which probably makes it super confusing. Because when I'm explaining it, I do the wrong thing, and then it crashes. And I have to be like, no, forget how that explanation worked. Actually, this detail is wrong. I'm surprised everybody doesn't take notes on like a little whiteboard or something.
So that we can just...
Well, yeah, and then when it's like verified, you take a picture of it or something, and then you start over on the next section. I take a picture every time the demo works. Okay. Oh, streamline. Nice control. So this is, you know, the funny thing is the line is actually in place. It's just commented out. Okay. So now let's see if it works. I think we've been to build it before. Oh, no. Oh, yeah, no, we had to build it before. Okay. Sorry, password. That's the right password. Okay, so there it goes. So you can see it's clicking and not clicking. So if I pull up the web browser.
And there it goes.
And sure, let's restore pages. Wait.
It missed.
it.
It missed again.
There. Oh, it went down, but it didn't go up. Okay, fine. There we got it.
It begins.
The president's like the other times.
This is...
Oh, the order some tabs. I'm not surprised to reorder tabs, I guess, since it doesn't click in. Oh, it closed the tab. Okay. Okay. Oh, now it's cutting it. Okay. That's RM1. Oh, that's not published. Okay. It's substantially more annoying now that it clicks. Okay. So, we've got an annoying program now. But it's really not very controllable. So this whole thing about mice and needing the mouse, I actually for a while had two mice plugged into my computer, believe it or not, and one of them sat in the usual spot, but the other one sat on the floor. And the idea was I could actually use my foot to move the other mouse around, so that way I wouldn't have to necessarily take my hands off the keyboard. And in fact, if I could click the mouse that was on the floor with my toe, you could do both at the exact same time. I thought this is a pretty cool setup. It evidently didn't work that great, so I don't use it anymore.
Well, you need a bigger mouse. That's your problem.
Maybe that's it, yeah. Yeah, anyway, so it's kind of nice to be able to control it from the machine. So we'll set up a way to control it. Instead of doing a timer fun, we can go ahead and set up an entry in /proc. Now, you don't need to set up an entry in /proc for Project 5. For Project 5, I'm figuring that you might be ready to be done with /proc files for a while. That was a general impression I got near the end of the project. So actually, you just register a keyboard notifier, and when certain keys are pressed, you go ahead and do things straight off without really worrying about making a /proc entry. We'll make a quick proc entry here, and then we can control the mouse from the console here, which will be handy. The kernel, we had lots of proc demos these days. The crypto one had a pretty good one. Yeah, this one. And that is write simple. So we go ahead and grab the whole thing there and append it onto our mouse thing, and we can sort it all out. Okay. Okay, so there's the new one, the proc one. We're going to need procfs.h, so we'll steal that line. I always feel sort of like some kind of, junkyard wars kind of contestant when I'm taking these demos and doing this stuff. What can we build out of this mess? Okay. Now CTL, so good. Okay, we don't need that. We don't need the read function. We don't need that. We don't even need that. We don't even need that one. We need the other one. Okay, this will actually be the right. It'll move the mouse. So I'll call it move mouse. That's all right. Okay. Yeah, you're going to have to do that. So put that up here. I don't necessarily need the timer stuff anymore. Okay. This stuff is not needed. That one's needed. Okay. So at this point, we should feel like we've taken the front half of a Ford pickup and matched it to the back half of a Geo Metro. And we can get started making this thing work good. Okay. Look at these. Did I just delete our right function?
I think you did.
There it is. That needs to still exist. Oh, and that needs to exist too. Okay. There we go. That part has to be okay. 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 So move the mouse. We still want to do this kind of stuff up here. We're going to grab that. We don't need a timer of that other than that. Okay. The user is going to write something to us. And they're going to write to us in this buff here. So once they wrote what they're going to write in here will be our control statement. Then we'll go ahead and take and assume it means we want to control something. So we define a simple grammar for control here. Say we have the operations U, D, L, R, and C. And C is a click, up, down, left, and right. Go, up, down, left, and right. And these are followed by a number. So we should expect to see a number after each of those. Okay. Should not be too hard. So the first thing we want to do, well, we want to do a couple of rationality checks here. We're going to count, which is how much they intend to write into the buffer, and we're going to buff. Now, it's good if you have a kernel module that the user can't use to crash the computer. Where this could be a problem is suppose the user wrote in a U, and we automatically assume it's got a number, but it doesn't have a number. So in that case, we don't want to crash the operating system. It'd be nice if we handle that nicely. Yeah, we could do that. Okay, so if count is not 0, we've got at least one character. And so we can go ahead and see if that is on that. Oh, the other thing about the click is you can click up or you can click down. Good point. So the click actually needs to have two options here. Because you can have a state, 0 or 1. So that needs a number too. So they all need numbers. Okay. Okay. So so it's going to have one of those things regardless. So count has got to be reasonable. So if count is less than 2, for example, there's really nothing we can do. It's not valid. We'll just ignore it. Return count and say we got all this stuff and it's fine. Okay, so otherwise we need to do a bit of a switch. Okay. So buff position 0 ought to be a letter, and so we can switch on it as a case. So if it's a U, we're looking for a number after it. Oh, we should get our number off here too. We should do that before we do it. Let's get our number. Okay, get our number N. So N. So we can use something like A to I on buff plus 1. The reason we can say buff plus 1, if we take the address of the buffer, we go one further, then we should be at the number that the user put in here. However, there's a danger here. The user might or might not have null terminated their string. If they haven't null terminated the string, then we've got a potential issue. We look at A to I here. A to I expects a character pointer right there in PTR. And so it converts the initial portion of the string pointed to by NPTR to an int. Behavior is the same as this thing right here, except that A to I does not detect errors. Cool. So that's what it does. Okay. So what we'll do here, a couple of things. First of all, we'll go ahead and take the user's buffer and put it somewhere. We don't need a lot of memory for this. Okay. In fact, since the user can't report a very high value on here, we really only need like maybe say 16. That'll be good because that aligns well on x86 memory architecture. Okay, so we'll go ahead and copy it. into our copy from buff up to your n I 16. That's our max, 15 is our maximum. Okay, and then at that point we should be able to say, as long as count isn't too high, we can say our copy of position count, LB1 past the end, is a 0. That'll make sure it's an alternating. But there's the issue that count could be too high. So if count is less than 16, that's fine. We can use count. Otherwise, we can use 16. Most people put parentheses right here because they think it looks nice. Okay. That should be safe.
Yeah, I think so too. When you're setting conditions, it's, I don't know, it does, it looks nice that way.
This whole thing here, we can do that earlier, later. Cool. Okay. So now we got our number here, and this will be, we'll copy it out of our copy. That's the number n. Okay. So case of U, input report rel, rel y for up. We're going up or down, I don't know. Probably positive. If it's backwards, we'll change it. Okay. Great. Case D. So D is just like this one, except we're looking for the other direction. Okay. Now the funny thing is about the other ones, they're pretty similar too. In fact, we're going to make a couple of copies of this. R, L. Okay. X, X. One's negative, one's positive. If positive, probably to the right.
Yeah.
Okay, well, we could be clicking. Okay. For key, finally something different. Okay, now the state. We could just throw n in there like that, 0 or 1, or whatever the user did. I don't actually know what happens if you give the state some high value, like 732.
We should find out.
Yeah, we can either find out or we can not find out. If it's true, 1, otherwise 0. That's how you not find out if you don't want to find out. But sure, why not? Let's find out. A lot of people like to put the break here. We could either put it there or we could leave it off. I'll put it there because it looks festive. Okay. So then we want to input sync. That was state thing is historical at this point. Go ahead and just eliminate historical trappings. The historical trappings in code, you can eliminate them like this for a clean look, but most people actually leave them in their code. Because that way you can come back at it from a genetics perspective and come up with a phylogenetic tree of which piece of code is descended from which other piece of code. Have a family tree of your code. Anyway, there we go. There's the mouse move thing. Okay, we create a proc file. Yeah, we did. We remove the proc entry. Yeah, we did. We unregister our device. Yes. So I don't have any really good evidence this will crash the computer. So I'll try it. Okay. So make. Ooh, couple of errors. Forgot a semicolon apparently. Right there. Okay. Implicit declaration eta I. Oh, that could be an issue. So perhaps you don't have eta I in the kernel. So sometimes people try to fix this by something like this. You can't do that. String is a user space library. It's not available in the kernel. So when you call something like strncpy, you're actually getting the kernel's other implementation of strncpy that happens to exactly the same thing. Since C programmers are used to basic library of functions, most of them are implemented in kernel, and most of the ones in the kernel work exactly the same way as user space ones. So you can actually read the user space man page and see what the kernel version of it does. Very convenient. Not in this case, apparently. Okay, well, there's another way to do this. Use scanf. So scanf right here, as opposed to scanf. Scanf takes a string and a format that we're going to look for inside it. And then it will hopefully find what we're after. Okay, so what we want to do with scanf looks like this. Go ahead and make n. We say scanf, and we say what string we want to scan from. That would be that one. And what pattern we expect to find, and then where we want to put it. There we go. Try that. Okay, that worked. Now I've got this warning here. Some people like warnings, some people don't like warnings. If we want to avoid the warning, all we have to do is put that right there. Okay. Okay. Okay, mouse control. Yeah. Set a kernel. So, okay, CSU, and now I'm administrator. Now, one irritating thing about this terminal is anytime I type, it makes my mouse disappear. Actually, I shouldn't say it's irritating. It's actually quite convenient, but it's irritating for us right now. Echo. So if I go something that's valid, U100 into proc mouse move. Oh, I have to go into. Oh, mouse CPL, as I call it. Okay. Well, that's not up, that's down. At least as most people will find it.
Huh.
So we should probably do a little sign reversal there. What about left and right? Are they backwards too? No, that's good. All right. That's pretty good.
Up and down.
Okay,
reverse.
so what do we want to select that input format conversions down there? What we need to do is, first of all, we need to be up a little bit. Say a little less, like about 50.
Close.
Maybe we should be, let's go D10. Hey, there we go, we got it. Okay, now let's get to the edge of it. So if we go like left 20, oh, I think we wanted right. So maybe right to 50. There we go. Okay, now we want to put the button down. C0, I think that's down. Okay, so now we want to go the other direction, left. Well, we want to go pretty far. Input
Right now, it
format
thinks that the mouse is down, right?
No.
No. Let's go back over there, and let's try C1 instead. Okay, now let's go. Is it right left 150? That wasn't quite enough. We need to go more. Maybe
little
we go
too
back
much.
right a bit. Maybe left just a little bit. Got it. It is selected. Okay, so now we can use the much superior keyboard instead of having to resort to the mouse.
That same action could have been completed with a mouse. Infinitely quicker, though.
I'm sure you can run a first-person shooter with this module.
Yeah.
With enough practice and, you know, a program that changes things around just a hair more than it is, you probably could.
Especially if your opponent is on like dial-up or something. Okay, so that seems to work. The up and down were backwards. You should probably fix that. Yeah, okay. Did I already have this open? Warning here. Okay. Cool. This worked faster than I thought it was going to.
It's confusing that you needed to flip the signs on the line, because, you know, you think Cartesian plane, go up is positive, down is negative.
Yeah, but the screen coordinate 0, 0 is off in the upper left.
Oh,
and then-
that's right.
Yeah,
So negatives automatically.
right. But if you're talking about OpenGL and 3D graphics, then it's the other way. Y is the normal direction, and some libraries are each way. Yeah, I mean, my advice on those is really just try one, and if it's backwards, switch the sign.
Well, I mean, if you're flying a plane, you pull down, go up.
Right. And some people like to set their joystick that way, and some people like the joystick the other way.
Mm-hmm.
Some people in first-person shooters see the mouse backwards too, but not very many. And some people see scrolling backwards. That's the one that gets me. And somebody hands over their laptop and they're trying to scroll, and their touchpad is exactly opposite the right thing. You just have to insert a negative sign, like between your brain and your hand. Incidentally, if you wear special glasses that flip your view upside down for like a week, eventually it'll look normal. Then you take them off and everything will look upside down.
They've
It's
actually
so
done
mess
that.
with your brain.
Okay, yes.
Apparently, that's actually how things work. As far as an image, as it comes through our eyes, it gets projected in the back, upside down, but our brains are upside down.
Yeah, it does. Okay, up is up now. Right now, it's down. Okay, so now that we've got control, I wanted to show you just another example of how you use the user space side of these things, like mouse CTL. First of all, we're administrative there. Okay, we might not have to be. Wrong. So if we do that, you can see permission denied. Let's try changing the permissions on it. Okay, there we go. Now users can do it. So if you have a proc file that has permissions, the proc files are normally set up so the user can't mess with them. But if you wanted the user to be able to, you just have to give them permission. Not very hard. Okay, so now we should be able to write a program that does stuff with the mouse if we want to. So suppose you're trying to win a first-person shooter against your friend, and your friend is using a mouse, and they are winning, and you don't want them to win, but you have remote access to their computer. Okay.
Flip
Call this
everything.
program wobbly.c. Okay, so in this program, we'll need to write the files. So we need STAO. I don't know if you need STAO. We need write. Write is actually unit std. Okay. Okay, so what we want to do here, okay, so we'll go ahead and start it. And then we'll go ahead and write some, corrections to where the mouse is. So if we look up random, there's an std-lib random here, which gives us a long thing. So there we go. So we can get a move here. But let's go ahead and set up a loop here. Okay, so inside our loop, we get a random number. And we'll modulus it by something, say 5. Be something we might want to adjust later. We're going to have to keep our file open. So we'll say fn, okay, that's our file, equals, I'll call it cf, control file, open. So we want to open proc mouse ctl, and we want to open it for, we can open it for w only if we want, with write only. Okay, so we should be able to write into it. So we're going to pick a direction as well. We say direction, I like our directions. We can make a little array of them. Say char directions equals, yeah, pointer here. Right. Okay. QDLR. Okay. So we can say we want, this is going to be our move there, right there. Char D for direction, equals directions at position, and say modulus 4 to put it into the right range. Okay, so that should give us a magnitude and a direction. I'm not sure if 5 is enough. Okay, so then we can go ahead and write it. So we want to write into CF, and we want to write the D there, and then the integer n. So we'll have to go ahead and make a little message here. Okay, so try a message. And it's not going to be very long. So message at position 0 is our direction. And then the ones above that, we got to write into it. So there's a sprintf where we say message plus 1 to go 1 past it. So we're going to leave that first character alone. And then we're going to write in a %d like an integer. And it's going to be n. Okay. I think it null terminates automatically. So there's our message. Then we need the length of it. Okay. So that should write that in. And at the end of the file, we want to close it. But when are we done? There's not really like a point where this loop ends. You're probably done when the user control sees it. So they control see it, we're going to have a signal. So if we look at, let's go back to our wobbly here. Now here, the software here. Sorry. Now, just for 30 examples, signal. It's a signal zombie. That's probably not the right one. Doesn't it always signal out? I could probably give you more examples of that. Maybe I'll call it like handle something. Oh yeah, there it is. So like for example, print messages, it looks like handles one and sig V. Oh, you have to handle that one, that's right. That'll be a good one. Okay. So we want up here to register, we need a handler. Okay, we need a signal from there. And this will probably be seg V, that's the only one we'll register. We'll just say close our file, CF. That means that's be global. Okay, and it'll exit the program. Exits in a library. That's looks like you guys could do. Looks like we already got that one. Should be good. Okay. So we got to handle our actually can't register our signal handler here. Okay. And what was the name of our function? Right up there. We already made. And then sig action. Sig units. Okay. Put a note in there just so you can see it's working. Maybe take the note out later. It's nice to see that things work.
Little report.
Yeah. Okay. One last thing. This loop is set to run at full blast. That may be way too fast. And so it could actually cause a real problem with race conditions or something that we haven't figured out inside our kernel module.
So a little bit of a pause, maybe.
Yeah, let's slow it down just a little bit. I don't want to go down a full second though. If you look at nano sleep, you can actually do a high resolution sleep. So nano sleep there takes a struct time spec. That's kind of a lot. There's also a U sleep. That looks easier to use. Let's use U sleep. That only takes one number. So U sleep, micro sleep, that's you write a number of microseconds. So, not include. Sorry, started in the wrong place. We just want to sleep, U sleep for, I don't know, maybe 1,000. Okay, so biologists and chemists and people never forget this. But sometimes it's harder for us in CS where we don't use like micrometers and stuff. So if you ever want a table to say stick to your table where you eat breakfast or whatever, memorizing these things, at least some of these things, can actually be pretty handy. So we're looking at nano sleep. If you need that level of precision, you need to make a struct time val. We just use micro sleep. So 1,000 microseconds is a millisecond, which is really not very long. So there's 1,000 of them in a second. And then you got centiseconds, which nobody uses, and deciseconds that nobody uses. We use centimeters, just not centiseconds. And then you got like no prefix, and then you got all the big ones. A lot of you are actually quite familiar with hard drives. Computer scientists sometimes don't know this half of the table that well, but we usually know this half up here pretty well, at least up to about tera. When hard drives are bigger, we'll know about peta. Okay. Anyway, all that said, no. There's this thing. So this is about right. Probably. Okay. Few issues. I didn't actually put stdio into this thing. Size of action isn't known. Action, what is that in that case? So if we look at our example there, print messages C, instruction action. There we go. So we said it's SA handler, it's set to handler, which is the same. Now we do that. Oh, we probably didn't include the signal at H. Oh, we good. Probably there's a prototype for that structure, the struct sig action somewhere that's not in signal.h, but signal.h includes the actual definition of it. And so the size isn't known unless we have signal.h, even though the structure itself appears to be known. Okay, implicit declaration of open. Yeah, open somewhere else, fcatl.h. Oops, that. Okay. Yeah, that's an open flag. Did I get that wrong? I don't use the right only all that often. WR only. I think I put the W. Okay. String.h. Yeah, let's see if this is there. Sure, string.h. Okay, so I think our mouse control thing is active, so let's try running the program. That might be a little extreme. Yeah, it's a little extreme. Yeah, let's go for like 5. There we go. Yeah, just try and win the game now.
Drunken kung fu.
Let's load up a shooter and see if y'all get a sequel.
I have my favorite one. I have my one I wrote on there. Oh, that's right. Okay, quick song, right? Yeah, even in solitaire, it actually.
Yeah, even solitaire would probably be challenging.
It's like a Lucy game. Just think of your bullet spreader.
Here's a game.
Okay.
Oh no!
Motion sickness.
Yeah.
That might be more than is really required.
It depends on the game. How hard you guys.
Isn't necessarily.
Yeah, that definitely makes it. Yeah. I had sort of better. I do.
Nice.
I'm not even sure I can click on anything on this menu in order to.
Can you just press enter?
I think I have to click on. There. That's close enough. What if I just click?
Hey, you did it. Oh,
Tab?
no.
Almost.
I don't think I can tab to that.
Oh,
There we go.
wow.
I think I better pick. Oh, no, I gotta pick. Okay.
Come on.
Almost.
Almost got it.
It's like trying to play a game with Parkinson's.
Almost.
Might be a bit much of a
No? I don't know if I can even get my game started.
I think what you need to do is,
Turn it off, start the game first.
yeah,
Oh, yeah, we can do that. Because that's just over here. But I think 5 is actually a little excessive. I think maybe like, well, 1 is 32. Okay. Okay, so there it goes. So I agree with the suggestion. Get the game started and then start the problem. Okay. Is there some reason that's not okay?
maybe press the instant action button.
At the top.
Oh no, we should switch that. Now everything just stopped.
It's probably loading.
Yeah.
Maybe. Nasty file name rejected.
Oh
I'm not sure what's going on with my game. I know I've played this game before on this computer,
Mhm.
but it doesn't seem like it's entirely happy. Because I thought I usually just do that and start single player and it works. But maybe it's nasty file name rejected it for some reason. I'm wondering if we did something really hard to it. Anyway, so, yeah, sorry about that. I don't think I have a real terminal on here either. Okay. Well, the module though, I think it's about set. The only thing we need left is the occasional random click to make it. Oh, here. While we're doing this, I'll probably have a game on this software. Yeah. This one here. Okay, it has to be installed in a minute. Okay, so when that comes in, let's go ahead and add the occasional random click. So we'll give it just like an odds of clicking each time that we do this. So then the chances of clicking, let's say n equals random, mod say, oh, I don't know, 10. Okay, and if that happens, we'll go ahead and click and then unclick. And then we'll resume wobbling. We'll give it just a moment held down. Okay, so if n is 5, okay, then we want to say our message equals click 0. Was it? No, click 1 is what puts it down. Okay, right here. It's that one right there. I don't mind. Well, actually, it'll be 2 of them. And then we'll say message equals C0. But we'll do a little display here. Say everything in a second. Okay. Which will throw off a rhythm of wobbling a little bit, but that's okay. Okay, so it's possible that we click as well. Okay. Apparently there's it's an int right there. And message is, oh, we have to get strcpy in. I just tried to Python it. There we go. Okay. There you can see it's clicking occasionally too. Oh, and it's stuck in. That's irritating. Oh, can I not click because of this? Okay. It hasn't clicked on this one. C0, frog, mouse, CTL. There we go. Now it's not clicked. It ended up in a clicked state when I removed it. And so we had to declick it before the computer would work right.
Fun.
Okay, so we'll see how well this works. Sudo sh. No, we don't need to read me. Sure, do that. Yeah, that sounds good. No, I don't like menus anyway. Yeah, go ahead.
Any questions?
There's actually a utility called yes. So you could say like yes, type it into, you know what I just did. It's the fun. And that way it will answer all of the questions for you at once. Okay. I sort of like our little program here, although it's also kind of an awful program. I should set this up on, say, the, okay. Not yet. We'll go ahead and put a delay on this. We'll say, so you can say like sleep 60, like that. So I'll go ahead and, do I need 20 seconds to get it going? Probably. Okay. Yeah. Oh no, I'm going to okay, I need to reset the board here. Okay. Now we probably want to get rid of that window too. There we go. Okay, so we'll see how well this works. This one you generally can just click this and pick something and play. Hey, I think we're actually going to be set up. I don't even know what the difficulty level is, but hopefully in about just a few, oh, hey, it's going, see that? Look at that, if I just like sort of stay here, it occasionally shoots. It does definitely make the aiming a little bit harder. I think the mouse sensitivity is not so much that it's like impossible, especially if I have the super shield pack. And it makes the shooting weird too. Like it doesn't shoot as often as it normally does. I think the boss is set up like easy.
At least the good news.
Oh, dude, I just hurt myself by firing a rocket randomly into the wall when I didn't mean to.
You gotta tell him.
Yeah, I did. It's gonna waste all my rockets. See, now I'm back to for some reason in the game, see, you have like this assault rifle thing, and it's like super, super ineffective. You can blast for like 10 minutes without hurting anybody. The wasting your ammunition automatically thing is maybe the most irritating aspect of this. Anyway, I would say in general it's probably fairly effective. I think it would be a definitive disadvantage to play with it on.
Yeah.
And in fact, you can see my cursor there. But I don't know what's going on now.
Oh, God.
It's switching when you click the mouse when you're dead. It switches between who you're spectating.
Okay. The other thing is, if you hold the cursor down, it sometimes shoots and sometimes doesn't because the two of them fight each other. It's like you really can't guarantee it's going to shoot. Like I should have had a headshot a moment ago. Oh, and then it respawns you because eventually it clicks. Okay.
Yep.
Oh, jeez.
Yeah, this is ridiculous. Okay, and I don't know if I can even exit the game actually. There.
Oh.
Okay. I'm gonna hang out over the button for a minute, but eventually clicks. Okay, well I think this would successfully work. I suspect that if you logged into the machine your friend was playing on remotely and started running this program, they would not win.
Yeah.
Challenge accepted. See, they wouldn't win until their skill gap rose to where they could actually handle that.
Oh, like eventually they just sort of figure it out?
Yeah, eventually they figure it out. And then that's when you turn it off, and suddenly they're just like so much better with the regular methods.
So
much worse. Well, no, because the way that would work is it would actually force them to like keep up with the timing and stuff and be focused.
Right, it'd be kind of like if you're training for a race, you just put 10 pounds of lead in your shoe, and then, if you've just been walking around normal for a few days, you're super fast. Is that what they do in cross country?
No. Oh, it's on their ankles.
You just run like some track people use like vests for like when they're not training, like to just walk around during the day.
Sure.
Yeah, a friend of mine does that. He's got a 30-pound vest and wrist and ankle weights he puts on and then goes on his track.
Yeah, we used to do ankle weights and arm weights and track and field.
So I never use them because I'm a distance runner. So it's like it's not.
I'm a distance runner, and we did that.
Okay.
Okay, so apparently there's some precedent, at least in the athletic world, for having a disadvantage that you learn to overcome to improve your performance. So actually, maybe this is actually a training aid.
Yeah.
I'm a faculty advisor for the gaming club. I should advise them to use this when they play.
Oh no.
Take
Take up the clicking thing and maybe.
I can hear it now.
We can actually make a program. Okay, where's the Okay, so a quick recap on this thing, and relating to Project 5 specifically. I realize that probably some of you will want to knock out Project 5 this afternoon or evening so that you don't have to worry about it again. So this has most of the pieces that you need. The Project 5, we look at the Project 5 description again. There's Project 5 right there. I don't know what all this stuff is about, like not using the mouse. I'm using it right now. It's eventually what you have to do. You have to register a keyboard notifier. Okay, that's actually a Project 3 thing, but everybody's probably got one around from the keyboard logger. So you got to go grab your keyboard notifier registration stuff. Look for presses of the arrow keys. So, you get a scan code for each of the keys. I'm just talking about these arrow keys right there. Mentioned in a moment, you don't have to worry about the numpad. The numpad, it depends if numlock's on or not. And, well, the issues involved in that. So you feel free to just ignore that one and use the regular arrows. So then, plus you don't really need both of them to work, you just need one to work. So then when each of the arrows are pressed, you're going to move the thing over a bit. And so you just have to do import, report, rel for whichever arrow key you got. Then there's these other keys up there. The pause key, I use the pause key all the time. The pause key sets my window manager to start listening for stuff. So like after that, I can do the terminal, and I can say exec Firefox, and then Firefox shows up. It can type very important commands. The reason pause does this, normally it's Control T on Rat Poison, which is ridiculous because that's a new tab in all the web browsers. And since nobody ever uses the pause key, I've hijacked it for my own use. But it's not very common. I mean, how many people here pressed the pause key in the last week? I guess I have to raise my hand. So, you did?
I don't think. Oh wait, there's a pause button, and it requires the function key. Okay.
Ooh, I didn't think about that.
Yeah.
That's my keyboard too.
Okay, if you have some weird problem with your laptop on that, feel free to substitute any other key for the pause key.
Any other key?
Any key you want.
Make it easy.
Yeah, you can make it like C if you want to. It's the same thing, like technically. It just seems like it would be a little irritating if it's one of the regular keys that you push all the time. But yeah, feel free to make any substitution you want.
Okay.
You can make a substitution for the arrows too if you happen to just not have arrows. I know people have arrows these days. You have arrows.
I
You have
have
arrows.
Most keyboards have arrows.
Okay. Everybody has the arrows. Okay.
Key that people lack these days.
Okay, so fine.
Yeah.
Arrows aren't a problem. But if the arrows were wrong, you can let us like WASD or something like that. That'd be fine. Don't hold yourself up over trying to get the exact keys I said here. I'll try and remember to put some sort of note in here to mention that. So anyway, when that's pressed, you just report a left button. And so the way to report a left button, you just report a key. Now, in order to click and drag, if you push down the pause key or whatever you use and hold it, it should be that it stays clicked. And so all you have to do is report that the mouse button went down when a keyboard button goes down. When a keyboard button comes up, report that the mouse button went up. And it should be good, right? Okay. Any questions? Does this sound easy?
It sounds like copy
Yeah.
and paste project.
Yeah.
Yes.
Oh, do you have a question or you just think it's easy? It sounds easy. Okay. Okay. I'm tracking who thinks it's easy. Because everybody who has it easy will make the deadline a week sooner. Okay, well, that's all I have for today. I was going to bring class evaluations, but I forgot them, and now we do stuff all the time anyway. So.